This code imports several libraries, pandas, NumPy, and matplotlib. It also sets the plotting style to work within the Jupyter Notebook environment. The code then sets the default figure size for any plots to be displayed as 15 by 6 inches. The purpose of this code is to ensure that the necessary libraries are imported and that the default figure size is set to a specific value for subsequent data analysis or visualization tasks. The given code reads a CSV file named fb.csv and stores its data in a pandas data frame object called data. It then displays the first few rows of the data frame using the head function. Afterwards, it prints the data types of each column in the data frame using the dtypes attribute. The code above is designed to read a CSV file containing Facebook stock data and parse the date column as datetime objects. The code defines a lambda function called dateParse that uses the structime method from the datetime module to convert the date string into a datetime object, using the format %y%m%d. The lambda function takes a single argument, dates, which represents the date string to be parsed. The code then reads in the CSV file using the read_CSV function from the pandas library. The parse_dates parameter is set to date, which indicates that the date column in the CSV file should be parsed as datetime objects. The index_col parameter is set to date as well, meaning that the date column will be used as the index of the resulting data frame. Finally, the date_parser parameter is set to the dateParse lambda function, indicating that this function should be used to parse the date column. The resulting data frame is then printed to the console using the head method to display the first few rows. The code is checking the data type of the index in the dataset. It does not manipulate or modify the data itself, but rather focuses on understanding the structure and format of the index. This information can be useful for further analysis or processing of the dataset. By examining the data type of the index, it allows the user to have a better understanding of the dataset and make informed decisions based on this knowledge. The code is designed to convert a column in a dataset called adjective_close into a time series. A time series is a set of data points collected at successive points in time, typically with equal intervals. The variable ts is being assigned to the adjective_close column of the dataset. The head10 function is then applied to display the first 10 data points of the time series. This code is useful when analyzing and modeling data that changes over time, such as stock prices or weather patterns. This code retrieves the value at the specific index May 18, 2012 from the time series data stored in the variable ts. It returns the value associated with that particular date in the time series. The code imports the datetime library and specifically the datetime function. The datetime function is then used with the argument datetime 2015, 3, 26, To create a timestamp object representing the date and time of March 26, 2015. The variable TS is not defined in the code provided, so it is unclear what the next step or purpose of the code is. However, it can be assumed that the intention is to store or use this created timestamp object in some way. This code is used to specify a specific range of data in a time series represented by the variable TS. The range is defined by the dates May 18, 2012 and March 26, 2015. By specifying this range, the code filters out all other data points outside of this time frame and only considers the data within the specified range. This allows for a more focused analysis or manipulation of the data within the given time period. This code is used to slice a pandas data frame object called TS. The slice operation is performed on the rows of the data frame using the indices. In this specific case, the slice operation starts from the first row and goes up to the row with the index March 26, 2015. The code uses the colon notation to indicate that it is slicing the rows based on their indices. By using the colon notation and specifying one of the indices to be at the ends, the code extracts a portion of the data frame up to the specified index. This allows the code to retrieve a subset of the data that falls within a specific range of indices. The given code selects all the rows from the dataset TS that belong to the year 2012. It filters the data based on the specified condition, which is the year, and retrieves all the rows that correspond to that year. The purpose of this code is to obtain a subset of the dataset that contains only the data from the year 2012, allowing for further analysis or processing of that particular subset of data. The code plt.plot_ts is used to plot a graph or a line plot using the data stored in the variable TS. The plt.plot function is a part of the matplotlib library in Python, which is commonly used for data visualization. By calling this function with the variable TS as an argument, the code instructs matplotlib to generate a line plot using the values stored in TS. This line plot can provide insights into patterns, trends, or relationships in the data, allowing the user to analyze and interpret the information more easily. This code is implementing a function called test_stationarity that is used to check the stationarity of a time series data. The function takes a time series as input and performs various operations to analyze its stationarity. First, it calculates the rolling mean and rolling standard deviation of the time series using a window size of 20. Then, it plots the original time series along with the rolling mean and rolling standard deviation. Next, it performs the Dickey-Fuller test on the time series, which is a statistical test used to determine if a time series is stationary or not. The test results are printed, including the test statistic and critical values. Overall, this code helps in analyzing the stationarity of a given time series data by calculating rolling statistics and conducting the Dickey-Fuller test. The code test_stationarity TS is the call to a function that checks the stationarity of a given time series, represented by TS. Stationarity refers to the property of a time series where its statistical properties such as mean, variance, and autocorrelation are constant over time. By calling this function, the code aims to analyze the stationarity of the time series TS to determine if it exhibits any trends or patterns that may affect its predictability. This is important in many data analysis and forecasting tasks, as stationary time series are generally easier to model and predict accurately. The function may employ various statistical tests and visualization techniques to assess the stationarity of the time series. The given code first takes the natural logarithm of a variable TS using the np.log function. The result is stored in a new variable called TS_log. The natural logarithm of a number is the logarithm to the base e, where e is a mathematical constant approximately equal to 2.71828. This transformation is useful in data analysis, as it tends to compress larger values and expand smaller values, which can help in certain statistical calculations. After calculating TS_log, the code uses the plt.plot function to create a line plot of the TS_log variable. PLT refers to the plotting library, while plot is a function that creates a line plot using the provided data. In this case, the TS_log variable is passed as the data to be plotted. By plotting TS_log, the code visually represents the transformed data on a graph. Line plots are commonly used to show how a variable changes over time or across different categories. This visualization can assist in understanding patterns or trends in the data that may not be apparent when simply looking at the raw numbers. The code calculates the moving average of a time series data, which is stored in the variable TS_log. The moving average is calculated using a window size of 10 data points. The parameter min_periods equals 1 ensures that the moving average is calculated even if there are fewer than 10 data points at the beginning of the time series. After calculating the moving average, the code uses the plt.plot function from the matplotlib library to plot the original time series data. This is shown in blue. It then plots the moving average as a line graph, using the color equals red parameter to specify that it should be shown in red. By plotting both the original time series data and the moving average on the same graph, it becomes easier to visualize the overall trend and identify any fluctuations or patterns in the data. This can be useful in various data analysis and forecasting tasks. The specified code is requesting the printing of a variable called moving_average. It is not clear from the code alone what the variable represents or the steps taken to calculate its value. However, based solely on the line of code provided, it can be inferred that moving_average likely holds the value of a moving average of some kind. A moving average is a statistical calculation that can be used to analyze data trends over a specified period of time. It is commonly used to smooth out fluctuations in a dataset and highlight underlying patterns or trends. The specific method and parameters used to calculate a moving average can vary depending on the context and requirements of the analysis. By printing the value of moving_average, It allows the user to view or utilize the result of the moving average calculation. This can be helpful in understanding the data being analyzed, making informed decisions, or further processing the result in subsequent code. The provided code calculates the difference between two time series datasets and then displays the first 15 values of the resulting difference. The first line of code subtracts the moving average series from the ts_log series and assigns the result to a new series called ds_log_moving_average_diff. Assuming both ds_log and moving_average are time series data, this operation calculates the difference between each corresponding element in the two series. The second line of code then displays the first 15 values of the ts_log_moving_average_diff series. By using the head15 method, only the first 15 elements of the series are shown, giving a glimpse into the differences between the two time series datasets. The code ds_log_moving_average_diff.dropNA in place equals true removes any rows with missing values from the data frame ts_log_moving_average_diff. The in place equals true argument ensures that the data frame is modified directly without creating a new data frame. As a result, any rows with missing values are dropped from the original data frame. The code ds_log_moving_average_diff.head displays the first few rows of the modified data frame ts_log_moving_average_diff. This allows the user to take a quick look at the resulting data frame, after the missing values have been removed. The code test_stationarity is being used to check the stationarity of the time series data passed as input, which is ts_log_moving_average_diff. Stationarity refers to a time series dataset having consistent statistical properties like constant mean and variance over time. By applying this code, it analyzes the data and provides insights on whether or not it is stationary. The code calculates the exponentially weighted moving average, EWMA, of a given time series data. It first takes the natural logarithm of the time series data, and then applies the EWMA function from the pandas library with a half-life of 12. The result is stored in the variable exploited_average. The code then plots the original time series data in blue and the EWMA in red on a graph. The last line in the code is currently commented out, but if uncommented, it would plot the EWMA using a black dashed line. In this code, the given time series data ds_log is first subtracted from the exponentially weighted moving average, exploited_average, to calculate the difference between them, which is stored in the variable ds_log_EWMA_diff. Then, the function test_stationarity is called, passing ts_log_EWMA_diff as an argument, to check if the difference time series is stationary or not.
The code subtracts the shifted version of a time series data from the original time series data, resulting in a new series called ds_log_diff. It then visualizes the ds_log_diff using a plot. The purpose of this code is to calculate the first difference of the time series data and display it graphically.